University Eminent Lecture Series from SRM University, AP. Day second, I'm happy and proud to host today one of the very eminent speakers, Professor E. Haribabu. I'll be glad to introduce to the viewers and audience. Professor Haribabu is an adjunct senior fellow at the Research and Information Systems RIS for developing countries at New Delhi from 2016 till date. He is also the former Vice Chancellor in charge at the University of Hyderabad. In addition to being an outstanding professor and researcher, Professor Haribabu held various administrative positions at the University of Hyderabad as Pro-Vice Chancellor, Dean, School of Social Science and School of Fine Arts and Communication. He was an adjunct professor, international programs at University of Iowa between 2007 and 2012. Professor Haribabu obtained his doctoral degree in sociology from Indian Institute of Technology, IIT Bombay. He earned his master's from the SV University with a gold medal. He started his teaching and research career from IIT Bombay, worked at NITI Bombay, IIT Kanpur and University of Hyderabad as professor. He's been teaching courses in the interface, if I may say so, like a set theory A intersection B intersection C kind of, the realms of science, technology and society, and continuing the research in the same area. Under his supervision, 24 PhDs, 18 MPhil degrees have been awarded. He published extensively in journals and journals of national and international repute. He has authored books. He has undertaken research projects by CSIR, DST, the Rockefeller Foundation, USA, the European Commission, and the IDRC, Canada. He has served and he continues to serve on various international bodies, committees on science and technology studies. He'll be talking to us on a very interesting idea, I would say. Technologies are not disembodied artifacts. I was almost like saying, wow, they are socio-technical systems. I would request Professor Haribabu to give us the lecture, and over to you, Professor Haribabu.
Thank you, Professor Desikan. Can you hear me?
Yes, please.
Thank you, Professor Desikan, for your kind introduction. And I'm very happy to be with you all today to share my ideas about this topic. And I've been teaching courses on science, technology, society interface for the last 2 to 3 decades nearly. So I bring in some of my insights into this lecture. Basically, I would like to see that all students who are going to listen to the lecture gain an understanding of connecting science, technology, and society, how they're connected, and how can one really understand these connections, right? So it's very, what happens typically is in engineering colleges and liberal arts science streams, each discipline tries to train students in their own disciplinary culture, disciplinary perspectives about nature, about the world, very rarely connecting that other disciplines are also interconnected. Not only other disciplines, but also they're connected to society. So that's what happens when you go deeper into a particular area and keep on digging into the depths, ever rarely coming up and seeing the world connecting it, how this discipline is connected to other disciplines. Right? So that's my endeavor today. And let me start my lecture. And today, we cannot talk of society without talking about science and technology, nor can we talk of science and technology without talking about society. They are pervasive in all domains of our lives. Uh, so let me see how, before we do that, basically, I would like to make a few remarks about what is science and what is technology, how they're connected, and how the relationship has been changing over time. Science generally is known as the act of knowing the world. Know the world, we raise questions, right? Right? What to know, how to know. What to know is something which is related to our interests, what part of nature we want to understand, and how to know is basically a scientific method of understanding it. Now, what kind of questions we raise when we ask nature, when we pose questions to nature? What is it is one question which gives us an answer about the nature of phenomenon. It's a description. How is it also gives description of the phenomenon and its relationship with other phenomena and its evolution. Why is it another question that all scientists raise, including social sciences who raise this question, this explanation, why the phenomenon is related to other phenomena the way it is related. So explanations are very crucial for any intervention. So then other question that we ask is, what will it be? It gives prediction. What will be the phenomenon like in future? And these predictions are based on our explanations. Explanations provide basis for prediction. So then what is technology, right? Technology can be seen as interrelated elements, artifact, knowledge underlying the construction of the artifact, and social organization that is required to implement the technology. Now, there are other aspects of technology which are important for us in this lecture and generally to understand uh, how technology operates in a context. One is the design aspect. So the technologies are designed to perform certain functions, right? A refrigerator is designed to maintain temperature at a particular level. The aircraft is designed to fly, and so on. There are other aesthetic factors associated with this design, which is in terms of color, in terms of size, shape, and so on. These are aesthetic factors which, as uh, consumers have several preferences. Right? Recent studies show, however, technology society interface studies show that the design incorporates the interests, values, and ideologies of technology developers. And also it incorporates power relations in terms of exclusion and inclusion. It relates to who will have access to this technology, who will not have access to this technology. These are built into the design. So that is why if you really want to understand what are the consequences of a particular technology, we should really unpack the design. There are several examples about how designers incorporate their values and interests. In the literature, I am not going to go into details. Perhaps I can give references to this. So then what is the relationship between society, technology, and science? Society is a condition for doing any scientific and technological activity. Society provides human resources, personnel, basically to carry out scientific and technological activities. Cultural resources, it provides us with language, beliefs and values and meanings. Language is extremely important in really expressing our views about our ideas. And physical resources include funds, it gives space, infrastructure. So, and society also accords legitimacy to scientific and technological activity. Legitimacy is based on two things. One, doing science and technology are worthwhile in their own right. And doing science and technology will help society in some future date. That's the reason why all societies accord support to science and technology activities. For example, science can be seen as a force of production because modern science enters production, industrial production, agricultural production in a big way. And also it can be seen as a force that changes our consciousness. We all know that earlier, about 16th century, Copernicus made his statement about the statement that it is the earth which rotates around the sun, not the sun which rotates around the earth. These are evolutionary statements which change our consciousness. And today, although we still see sun rising in the east and setting in the west, but actually we live in a context where we understand that it is the earth which moves around the sun. So this is how science changes our consciousness. For example, another example one can give is the Human Genome Project revealed us that 99.9% of human population, their genome is similar. Only 0.1% is different, accounts for physical appearances and other features. So this is how scientific knowledge has been changing consciousness and changing society by contributing to production. Similarly, technology, of course, we'll see in more detail later on when we go into we go ahead in the lecture. Now, let me just draw your attention to the fact that earlier, how people conceived relationship between science and technology. Earlier, people thought science is a noble act of knowing, right? Knowing the world, right? Knowing the universe. And technology is the act of doing. Basically, you mop up the knowledge and try to construct some artifacts and so on. Later on, people said, no, they're all symbolic. They have symbiotic relationship. Science and technology are actually parallel structures and have parallel cultures. One important contribution that was made by Derek Disolo Prize was to say that science and technology are parallel cultures. He says the most important feature of science is that scientists are papirocentric. They want to publish their findings as early as possible, whereas technologists are papirophobic. They don't want to publish papers because the technologies are connected to patents. So that's the distinction you do. And then now today we talk of technoscience, which obliterates the distinction between science and technology, and they are seen as interpenetrating systems and also interface with society in various ways. So now today, people talk of technology as a knowledge, and actually terms like science and technology are historically produced. Sometimes science and technology mean the same thing. For example, nanoscience and nanotechnology are indistinguishable today. Let me also say that the internal world of science, by which we mean theories, models, methods on the one hand, and external world of science, the economy, politics, social structure, culture on the other, are intimately related. And this has been shown in several scholars in the field of technology and society interface. We'll also see that in this lecture. Yeah, earlier, people thought these technologies which determine the shape of society. That's called technological determinism, which means that technology shapes society, and technology is an independent force, and technology has the autonomy. And given a technology, there will be a particular kind of society. That's why sometimes people give this quotation of Marx, who said, a watermill gives you a feudal society. But today we can say a microchip gives you an information society. This is called technological determinism. And so let me read out a particular quotation by Mackenzie and Beckman. Scientists discovered technologies follow the logic of those discoveries, turning them into new techniques and devices. These techniques and devices are then introduced into society as innovations, as we are familiar with. As I said, technological determinism is no longer seen as a kind of a theory that really will help us in understanding the interconnections. You can't say that a microchip gives you an information society. We would like to see how the microchip was invented, what were the kind of knowledge knowledge is, what was the kind of knowledge that underlied this construction and so on. We'll see these are important kind of factors that we should understand. So we shall see technologies are shaped by several factors. See, these factors are economic factors, which emphasize efficiency and productivity. We would like to do things more efficiently, so we need more techniques, newer techniques. And social institutions also influence development of technologies. Actually, all economic factors in the last analysis are social in nature. They're related to social institutions. Political power also is important in shaping technology. For example, if you look at all the technologies have a political dimension. For example, even society will decide what kind of technologies to be adopted, at what scale they should be adopted. These are all political decisions today. Another example is atom bomb is basically a political instrument, a political weapon. There's no other purpose except political purpose. Right? Cultural factors also shape technology. For example, creative pursuits like science itself is a creative pursuit. Technology is a creative pursuit. Apart from this, fine arts is important in our lives. Everywhere, these factors shape our technologies. And also our systems of meanings, right? The social world is a world of meanings. We attach meanings to various objects, events, and practices. And we would like to see how to conserve our meanings by perhaps developing new artifacts. Then existing knowledge also helps in shaping, giving rise to new knowledge. And science, of course, modern science is basically is the bedrock of modern technology. The technology predates modern science. Even before modern science became a system of knowledge, people were using technologies like people used the chariots, people used bows and arrows, and so on. Look at the consequences. There are also economic consequences. By improving productivity and efficiency, we generate wealth. And social institutions, technologies also lead to social changes in the society, change in the institutions. Technologies also have political consequences in terms of distribution of power. Technologies can help lead to centralization of power or decentralization of power. And cultural changes means technologies can change our attitudes, values, and meanings. For example, information technology has really changed our attitude towards our interaction with others. For example, mobile phones. Nobody writes letters to people now. It's all on phones. We talk to people on phones. And the very attitude of people towards our meanings have changed. Attitude towards objects have changed today. So similarly, the other literature has been generated as to how technologies influence environment, because the whole debate on climate change is related to consequences of technologies. For example, greenhouse gases and anthropogenic factors has really contributed to environmental degradation and climate change and so on. So I think that's how we should understand the relation. It's not a monocausal kind of a relation between technology and society, but several factors influence development of technologies. And the most important thing I would like to mention in this lecture is technologies are not context neutral. So technologies are introduced into a particular society, a particular structure, particular culture, particular political milieu. So earlier people thought technology is neutral. Wherever you introduce technology, you will have same results, right? It will do the same kind of thing. That's not the way it's working now in various contexts. As technology is shaped by various factors, it operates in a social, cultural, and economic context. So hence, it's not a neutral kind of force. Various interests are involved in shaping technology, as we have seen earlier. As mentioned earlier, recent studies show that the design incorporates interests, values, and ideologies of technology developers and power relations, which basically translates into exclusion and inclusion. Which section will have access to technology, which section will not have access to technology. It is accessible and it is affordable, and so you promote inclusivity of technology or inclusive feature of technology. We are going to look at the relations between the context and technology by focusing on biotechnology in this lecture. We all know that biotechnology includes several techniques. One is, of course, fermentation, which has been old kind of a technique. People have been using it. Tissue culture is another kind of technique where we try to cultivate elite mother plants by in a tradition, and then transfer them into a kind of the greenhouse and then hardening the soil. So today we have many products, crops which are produced by tissue culture. One example is bananas. Most of the bananas today are produced by tissue culture. Bamboo is produced by using tissue culture. Horticulture plants are produced by tissue culture today, and so on. Several kind of crops are now using tissue culture to produce high quality plant material. Cloning is another one, which where you can clone an animal from uh, uh, a species by using the cells of uh, uh, an animal, and its cloning is ethical practice, whether one can clone it. Cloning basically means you try to produce photocopies of a particular animal or particular plant. But people are, especially when it comes to cloning of animals, cloning of human beings, it's become highly uh, questionable because ethics are involved, morality is involved in this. Whether one can tamper with the integrity of an animal, whether one can tamper with the nature, can one play God by sort of cloning activities. Other technique is genetic engineering, which is also is important technique. By genetic engineering, several crops have been produced. We're going to look at these crops and see how they produce, what are the consequence of these genetically engineered crops. Latest technique is gene editing. Today, people are saying that we don't have to transfer genes from one organism to another. We don't have to do genetic engineering, but we can edit genome of a particular organism, edit the genes. For example, editing involves removing genes which are harmful and introducing genes which are uh, uh, beneficial. So basically, gene editing means you produce gene-edited babies, gene-edited crops, which also has several controversies around that. Now, there is a pause on this new technique of changing the genome of a human genome or not genomes, because there are ethical questions involved in this. I think now we are going to focus basically on genetic modification of plants and animals. And this is what has been uh, going on for quite 2 or 3 decades everywhere in the world, in our country as well. So what is genetic modification? Genetic modification involves we transfer genes across species, right, from one taxonomic group to another taxonomic group. For example, BT cotton is an example of a genetically modified crop where a toxic gene from Bacillus thuringiensis, which is a soil bacterium, is introduced into cotton plant. The logic here is this BT toxin will attack the pests which feed on cotton plant and protect cotton plant. Earlier, bollworm was the most serious pest that cotton plant was exposed to, and BT toxin really kills these pests which attack the cotton plant. So you are equipping the cotton plant with this toxin so that it can fight the pests like bollworm. So that is the today in our country, most of the cotton cultivated is BT cotton, or 90% of our cotton crop is BT cotton crop. So there are also attempts to introduce genetic modification in food crops. Genetically modified food is that food produced from genetically modified seed or food that contains ingredients made from genetically modified plants or animals or microorganisms. In the US already, they have these genetically modified crops. They have BT corn, they have the soybean crop, which is herbicide tolerant soybean. That herbicide is genetically engineered into the soybean plant. And they also have a tomato, genetically modified tomato. The logic of US is that they follow a principle called substantial equivalence. The US Department of Agriculture says that food produced by either genetic modification or hybridization are same. There's no difference. So that's why we accept genetically modified food. We don't really make a distinction between GM food and food produced by hybrid plants or hybrid crops. But it generated several controversies and also called for regulation in various countries. In our country, the GM debate, in India, attempts were made to introduce BT brinjal, but now there is a moratorium on BT, on commercial introduction of BT brinjal, because brinjal is a food crop. Brinjal is cultivated all over the country and it's used very, very frequently in our cuisine. So people are worried about what are the consequences of eating brinjal maybe 3 times a week or for a few years, right? So this is where India stands. And in India, there are a lot of controversies raised by farmers, raised by non-governmental organizations. And ultimately, Supreme Court had to intervene in this whole question of introduction of genetic modification. We'll see some of these later in the lecture. Logic underlying genetic transfer is that foreign genes inserted into the crop plant have some properties of increasing yield or production of a toxin that will equip the plant. We have seen that in the case of BT cotton plant. Increasing tolerance against drought and salinity. For example, we would like to see in our drought-prone areas, we would like to cultivate plants which can tolerate drought. Similarly, in saline areas, we would like to see that the plants tolerate salt concentration in the soil and it can be cultivated in saline soils. So I think there are, the logic here is you can transfer genes from plants which have high tolerance towards salt to plants which have low tolerance, and you can still grow them in saline conditions, right? I think this is the logic, but logic makes scientific sense, but when it is introduced into the societal context, it generates several kinds of controversies, several kinds of anxieties among people. Well, let me say this: genetic engineering is not purely a scientific act. It is connected with scientific, technological realms, government policy, domain, industrial interests of farmers and consumers, and of course the environment. That is how the so-called scientific solution or scientific kind of invention of a BT cotton or BT rice, whatever crops, they are not simply scientific acts. They interact with society in a very, very intimate way. And there are legal issues involved, there are ethical issues involved, there are judicial issues involved. And we have seen in the case of BT Brinjal debate, the Supreme Court had to intervene to see that the regulatory process is transparent, regulatory process is objective. So I think today's context, we cannot say science has the authority, or people have to accept this authority. That authority is being questioned by people at large. So that is why the so-called the scientific kind of solutions are discussed in public. Scientific ideas are gone into public arena, public discussion, right? So what are the various stakeholders in the entire genetic engineering technology? The industry is involved. Industry's interest is in making profits, and industry's industry's meaning system. Organisms are the parts or means of production. Organisms are the parts of organisms or means of production or some kind of raw material. What are the scientists' interests? Scientists' interest is the advancement of knowledge, and their interest in the current context of IPRs, they want to patent their knowledge, they want to make it a commodity and have patent rights over it. In their meaning system, scientists say DNA is DNA, whether it is it belongs to an animal or a plant or a bacterium, there's no difference, right? Hence, the DNA is transferable. That's the argument that scientists put forward. The farmer's interest is that they would like to obtain a quality seed and enhance production, and also marketability of grain, and of course, ultimately they want to make some surplus out of agricultural production. Then there are others. The government is also interested in the kind of innovations, agriculture innovations. Or governments have to ensure food production and at the same time minimize risks and ensure safety of technology through regulatory bodies. The interests of consumers, basically their interest in health and safety of food. Are you raising your hand? The interests of consumers is health and safety of food, and their culturally mediated aesthetic considerations such as size of the grain, shape of the grain, and color of the grain, etc. Taste, of course. These are the meanings they attach to food. For example, if you look at rice eaters, they would like to eat very fine quality rice, long grains, white color, and so on. At some point, a lot of hybrid rice was produced. Hybrid rice tends to be sticky and small grains. A lot of people have problems in accepting hybrid rice because the shelf life of hybrid rice also is not very long. So that's why acceptability of hybrid rice is very low in basically rice-eating areas of our country. So this is how society culture affects the kind of technologies that we produce. The Chinese don't have a problem in eating hybrid rice because they use chopsticks to eat rice. Right? They don't feel the grain, they don't feel the stickiness and so on. Perhaps that could be one reason why hybrid rice is highly successful in countries like China. Of course, in India, hybrid rice, a lot of hybrid rice is produced today. That is used to make intermediaries, and in some areas, hybrid rice also is consumed. So, that's engineering. Then one more thing is we should talk about regulation of these technologies. Basically, a regulatory architecture of any technology should keep in mind the safety aspect of technology, which is important in ensuring health of people if they get exposed to these uh, genetically engineered foods, genetically modified crops, and so on. And that's why regulation becomes extremely important. Now, why genetic engineering is being challenged in our country is because the regulators have not taken into account the interests of the consumers, interests of the farmers, and the regulatory mechanisms came from the actually they are imported from US earlier to start with our context. So that's why it's very important that regulatory mechanism becomes more transparent, more context related kind of a regulation. So it's more democratic in its function. Then perhaps technologies can acceptability of technologies and introduction of technologies may become successful so that there is a, a regulatory mechanism which tries to take into account the safety and health of people. So if you look at, as I said, technologies transform societies. In that sense, genetic engineering technologies have a potential to transform nature on the one hand. It is by genetic modification, you are introducing new kind of plants, and it also affects biodiversity. That's another argument people put forward. Genetically modified crops can reduce biodiversity. For example, BT cotton today has eliminated all cotton hybrids from the market. It is BT cotton which is now available in the market for farmers. Second generation BT cotton. So it also changes social structure by producing, for example, relations between farmers and tenants, farmers and agriculture workers, and society at large. As I said, in addition, issues of safety and risk for human beings, non-human life forms are also important when they're exposed to these technologies, what happens to them, and environment, what happens to uh, uh, other life forms. For example, what is the impact of BT toxin on harmless insects? What is the impact of BT gene on useful kind of insects? These are the questions that people keep asking. So it is a kind of situation when we see Thomas Edison, when he invented the electric bulb and he wanted to introduce his innovation to the market, he had to deal with scientific and technological issues, also interact with government regulators. He also had to contend with the rival companies, which were gaslight companies those days, financial issues that he had to deal with, and organizational issues. How does one take the electricity to the households? It's not enough to invent the bulb, but that bulb has to be used by households, and households should have electricity supply. All this he did in order to introduce electric bulb in the American society. So his invention led to changes in the society. For example, the moment electricity came, a lot of things have changed in the household level. You have a lot of electrical gadgets, you have electrical lighting system, and so on, which has really changed the relations within the family and outside the workplace, right? So I think when we talk of an innovation, when we talk of a technological artifact, it's not enough to have the artifact, but it also has to be seen that this introduction of the artifact takes place in a social context, and the inventor or innovator has to really interact with all several domains in the society at any given point in time. So let me say something about risk. A risk is potential harm to life, property, and environment. No technology is risk-free. There are two important dimensions of risk. One is judgment on the acceptable level of risk. What is the level of risk that we should accept? And time element. Judgment on acceptable level of risk is never purely scientific. And the weighing of incommensurable costs and benefits involves diverse values. Hence, culture of regulation varies across the countries. For example, whenever we accept what is acceptable level of risk, it is never purely based on scientific considerations. It is commercial considerations, it is economic considerations, and so on. So, in that sense, these judgments about risk are also related to regulation, related to government policy, related to society at large. So, so there is a need for example, regulating risk, assessment of risk, and then regulating it. So, this is an acceptable level of risk. Decision on acceptable level of risk always is negotiated outcome mediated by power relations among the actors and the institutions that they represent. Secondly, time dimension refers to how long a particular technology is safe. Regarding time element, the request for what time frame is for which, for example, in the discussion we had on BT cotton, how much time BT gene will confer the resistance against bollworm in cotton. This is a important question today. Way back in 2002, they introduced the first generation BT cotton seed, and it worked for about 6-7 years. And then the bollworm developed resistance against this BT gene, and they started reappearing. Then the company which produced first generation BT cotton seed produced a second generation BT cotton seed by putting one more gene into the seed. And second generation worked for some time. Again, today we right now are faced with the reappearance of bollworm. We don't know what to do, how to fight it out, because the company which produced second generation, first generation BT cotton seed, Monsanto company, has left the country. They left our country because they found India regulation is very uncertain. Because in our country, agriculture is both a state subject and a central subject. Central government passes policies, state government sometimes implement, whereas state government says agriculture is our state subject, so we will do whatever we want. That's how the earlier cotton seed price was controlled by the state governments, and also the central government gave a ruling on this price. The company did not like the kind of uncertain regulatory environment. They left. And today, Monsanto has a Bollgard 3, third generation BT cotton seed, to which we don't have access because they're not selling it to us. Now we are stuck with this bollworm. And in our recent study we published in the journal, we found out in Telangana region, pink bollworm infestation has become serious, and it's going to be more serious. And we don't have a solution to this problem. We don't have third generation BT cotton seed. So I think it's very important to keep this dimension of efficacy of technology in mind, and continuously we should evolve, see that these technologies are updated, and also these technologies are accessible and affordable. So, as I said, how do we assess the risk? Different actors, scientists, government representatives, and regulators, sometimes industry representatives assess risk from their own perspectives, right? So each industry says industry's method of assessment is one kind, government's method of assessment is one kind, and people's assessment of risk another kind. It's more, people do risk assessment more in their own cultural terms. There is this problem of framing risk. How does each group frame the risk, notion of risk? They try to frame the risk in terms of their own interests, their own perspectives, which can become a problem sometimes. That's why today the literature on science society interface says scientific judgments are not immune to social, political, industrial, and cultural influences. So I think today's context, we cannot say science is autonomous, independent, and so on. Science is very much part of public arena. And so let us look at what's happening. A couple of more slides and I'll end my lecture. In USA since 1990s, largest area of land in the US has been devoted to genetically engineered crops, cotton, soybean, tomato, corn, and so on, food crops also. The US crops based on transgenic seed and crops based on conventional hybrid seed are treated as substantially equivalent, which I just pointed out. American people have been consuming genetically modified food. There they say, let us see what happens after we consume food for some time. That's their attitude. Regulators tend to think that mandatory labeling would send wrong signal to people regarding safety of genetically modified food and thus create confusion among people. That's why US, they don't believe in labeling genetically modified food. Genetically modified food is seen as substantially equivalent to food produced by hybridization techniques, hybridizing methods. So there is no labeling process, whereas in Europe, there is a problem. They don't accept genetically modified food. In Europe, consumers and their organizations, civil societies at large have been resisting genetic modification of food crops. Genetically modified food is seen as unnatural and it may be risky for human health and environment. According to European Network on Safety Assessment of Genetically Modified Food Crops, it says the public concern is not only on, not only on safety, but also questions such as who benefits, what are the kind of harmful effect that this genetic modification has, how does it contribute to sustainable agriculture? These questions are raised in European context, whereas in US, they don't seem to be concerned about this question. They say that genetically modified food crops are equivalent to food crops produced by other methods. In India, genetically modified cotton is the only GM crop that's cultivated at present. Government has not permitted cultivation of genetically modified food crops. In India, the questions that are being raised regarding genetically modified food are similar to those raised in European context. In addition, the most important question that we should be concerned with is access to proprietary technologies, because BT cotton seed is a proprietary technology produced by Monsanto company. And what the question in our context, Indian context, is to what extent these proprietary technologies are accessible and affordable. So this is a question that we should raise, especially given the fact that in our country, majority of the farmers are small and marginal farmers, and their resources are very, very limited. How does one ensure that they have access to these technologies? Let me give one more example here. According to Monsanto company, when you plant BT cotton seed, you must maintain refugia. Refugia means 20% of your land where you grow BT cotton, 20% of that land must be devoted to conventional cotton. And the logic is that if you grow conventional cotton along with BT cotton, the insects will go and eat conventional cotton, and thus you delay the resistance in the insects for BT toxin. In the sense, you can use BT toxin for a longer time, BT cotton seed for a longer time. But many people found it difficult to maintain the refugia because a small farmer having 3 acres of land cannot devote 20% of the land for non-conventional, non-BT cotton, because he thinks that's a large chunk of land where you're going to forego the kind of benefit that he's going to get by planting BT cotton seed. I think these are the important questions that we should keep in mind. Our country, the policy regarding whether or not to introduce genetically modified food crops is yet to be decided. Scientists and regulating bodies are in favor of commercial introduction. Industrial lobbyists are in favor of commercial introduction. The government policy presented by Ministry of Environment and Forests is against this policy. They said that's why they imposed moratorium on the commercial introduction of BT brinjal. Farmers and CSOs, they also don't have any consensus on whether or not to introduce the genetically modified crops. So what I'm saying is, at the end of this lecture, today's technology cannot be seen as autonomous, as independent force. It is very deeply connected with policy, regulation, interests of scientists, interest of industrialists, and interests of consumers at large. So it can no longer be considered as an autonomous, independent force. That is why there is a lot more need for discussing the technological introduction, discussing about introduction of technologies in the country. And this, we should move from regulation of technology to governance of technology. Governance means governance involves a wider section of the population. The concerns will be taken into account before we really accept a particular technology for adoption. So this is my last slide. Recently, I recorded 30 hours of lectures on science, technology, and society interface for Swayam Prabha DTH channel 16. People can access these lectures. They're about 30 long hours of lectures, almost equivalent to 1 semester long lectures. So I end my presentation. Thank you very much for your attention. Is there any questions? I will try to answer them.
Yeah, thank you, Professor Haribabu, for that thoughtful, sharing of your ideas, and it was quite useful also, I would say, not just to the students, but to the faculty as well. I would request my colleague, Professor Kamesh, to kind of, anchor the talk from now on. You can interact with the panelists and the general public. And Professor Kamesh, please take this forward. Thank you very much.
Thank you very much, sir. May I request the panelists and other members who joined the discussion to come forward with their ideas, comments, questions, to have a fruitful interaction with Professor E. Haribabu. You could raise your hand or you can type it in the chat box. I'm looking at the chat box, sir.
Any questions in the chat box?
Not yet, sir.
Not yet, okay.
Mr. Kamesh,
Sir.
May I come in? I have a small clarification.
Please, sir.
So this is with regard to technology adoption.
Yes, sir.
The success of technology influencing culture largely depends on how technology is adopted or absorbed. Different types of technologies have different speeds of acceptance, adaptability, and absorption. Okay? So, in that sense, we have varieties of technologies carrying varying levels of adaptabilities. So, in this context, how do we broadly configure the link between technology and culture?
Okay. Can I answer?
Yeah, please.
See, what do we mean by culture? Culture includes our values, our meanings we attach to objects, events, practices, and so on. The kind of values we attach to, again, objects, events, and practices. And of course, our values and meanings are very much linked, actually. They generate some attitude towards particular technology or a particular practice and so on. So technologies also influence culture, right? Sometimes cultures give rise to new technologies. Sometimes technologies influence our culture. See, for example, all technologies try to change our attitude towards objects, events, and so on. Basically, technologies try to change our attitudes, values by trying to tell us, especially through advertisement, that the older way of doing things is inferior. But if you adopt this new technology, it is better, more efficient. It will make you more efficient, better, and so on. So that is how the technologies change our culture, attitude toward life, attitude toward objects, and so on. So that is how today's, as I said, today's context, the cell phones have changed our attitude towards our conversations, attitude towards our communication, and so on. Okay. So, did I answer the question?
Yeah, just a supplementary thing.
Yeah.
In that case, we cannot say that technology is not culture determined.
Culture also can sometimes determine. For example, see, if you look at our creative arts like music, sculpture, and so on, a lot of new technologies are introduced. For example, if you look at a music concert, nobody uses traditional tambura, right? It is electronic tambura, right?
Yes,
A small box people keep, the performer keeps aside and operates it, right? So that's how the electronic tambura came into existence because of its role in our music concerts. Right? Similarly, some smart aleck recently developed an electronic tabla, right? So it's available, I think, in the West. Electronic tabla is available today. Right? So I think tabla is part of our creative art performance, music performance, which was which gave rise to a new electronic kind of tabla, new electronic kind of tambura, right? So that's how our culture also can generate new technologies.
Yeah. Right. Right.
Professor Lakshman Rao, you have anything to say? I mean, you have any questions or contributions to this discussion? Professor Lakshman Rao.
Yeah. Thank you, Professor Kamesh, and thank you, sir, for your excellent presentation. So just taking the cues from the previous discussion, previous questions with respect to culture, am I audible?
Yeah, you are.
I can hear you.
Yeah. So the same thing, recently we have with this repairing technologies, especially
Mhm.
Many of the organizations as of now not adopted these repairing things because of this IPR and other things. And
Correct,
they
yeah.
want to protect their technologies, and ultimately they have not given to the society or to the customers to go with repairs on their own. And
Yeah.
what about your take on Indian counterpart? Whether Indian organizations are ready to go with these kind of things, because in US already they're legalized, but in India still the regulatory things are not in that way. What your take on that? Can you share?
See, for example, MS Office, you cannot do anything to that, right? Microsoft Word, you can't touch it, right? No way you can do any small modification. That's why the response was the open source software, right?
Yes, sir.
Open source software is where you contribute to the development of software. The open source software is the code is made public, code in which you write your programs, so that others can share it, others can use it and develop it further, right? So the whole response of open source software was because proprietary nature of the software that we see in the case of Microsoft Word or other
Products.
software processing software, right? So that is one response. Today we are increasingly saying that we should move in the direction of open source innovations, agriculture, in where open source innovations are affordable, they are accessible to people. They're not proprietary technologies in that sense. For example, the whole question of BT cotton, access to BT cotton, affordability of BT cotton seed is a proprietary product, right? So that can restrict access and affordability, access to technology and affordability. As I mentioned, today the pig bollworm has reappeared in our cotton fields. We don't have a solution, although Monsanto company has Bolgard 3, third generation BT cotton seed. They're not giving to us because Monsanto company has left the country, saying that in India the whole regulatory mechanism is very uncertain and several sort of agencies are involved. We don't know with whom we should really negotiate and so on. So that's why there's more emphasis on open source. And some companies, if they allow you to sort of repair the gadgets, their kind of products, that's a welcome thing, right? We should also, in India, we should allow that. But there is a great deal of discussion in open source software, open source innovations in various fields.
Thank you, sir. Thank you. Yes.
Dr. Supriya, since language is an essential component of culture, which represents a particular society's attitude towards anything that they look at. You have anything to discuss on this? We are in a generation of people who are majorly addicted to the technology, which is reshaping their language and cultural patterns, including the family structures. Dr. Supriya, are you there?
Yes, yes.
Would you like to say anything?
See, language is part of our culture, right?
Yes, sir.
There is a saying that if you lose your language, you lose your identity. And if you lose your culture, you lose your entire repertoire of your culture, right?
Yes.
Which, if you lose your language, the entire culture is embedded in language, right?
Yeah.
You lose that, you're going to lose this identity and culture. But what is happening today is in the name of I mean, we don't connect our children to our own languages, right? The connection is snapped, right?
Yeah.
See, especially where Telugu, Hindi, or Kannada, Tamil, Malayalam, see, we are disconnected from our own cultural heritage. We're disconnected from our own languages. So you don't know what our cultural heritage is, right? That's the problem, right?
Yes.
There must be some attempts to really sort of really bring them up into the new kind of era. I think there are attempts being made. In today's context, we can learn Sanskrit on internet, languages on internet. Yes, there are attempts being made for classical forms of performances are available on net. People are trying to sort of learn them and also propagate these practices, right? One important thing is every child must learn his or her mother tongue. And in our country, our languages are very, very rich, old languages, which really produce enormous amounts of literature, enormous amounts of knowledge about culture, right? About our identity and so on. So we should really access this, have access to this cultural heritage. Right? No question.
Very interestingly, so you have actually talked about language being the center of culture. In fact, one of our discussions with my students in the communicative class was the idea of accent. So it seems while in one of the trainings, they were told that they need to have an American accent so that they can get into a job. And there was a huge debate about what does that mean? Like, does it mean that my regional accent would be an impediment to getting a job? And so the entire idea of culture, region, language, that is sort of very important and impertinent for the student community right now.
Yeah, see, you can't connect language to merely getting a job, right? The moment you do it, you try to really reduce the scope of a language, right?
Exactly so.
So, language is a very, very important resource that we have at our disposal. Without language, you can't even communicate your ideas, scientific ideas, technological ideas, right? That is very important, right? So if people just because for a job, if they want to change the way they speak, forget about the language, that can be a problem. So there is a film, I don't know whether you watched it. I think you must watch it on the internet. There's one film called Outsourced, right?
Yes.
So you must have seen that. How
Yes.
Indian call center staff are being told to change their accent, change their names and so on. So people get confused with this, right? So I think it's very, very important to retain our cultural heritage. Right? That's what will give you an identity in the world, identity, and which is very, very useful to negotiate with the world. Right?
Yes, sir.
Thank you, Dr. Supriya. Anybody else would like to have a discussion here on the forum? Sir, should we assume that there are no more questions, or Professor Desikan, are you there? Oh, maybe you would have gone for another important meeting. Sir, in that case, I would like to summarize with my little experience on the areas that you have spoken and my current engagement. Sir, your session was focusing on the interaction between science, technology, and society, mostly on technology and society and technology and culture. Started with the technological determinism, saying that technology will shape the society. Currently, you have touched upon the various streams like biotechnology to information technology and nanotechnology, and you try to speak about the triple helix, the relationship between these three aspects: science, technology, and culture. Especially in a university like SRM, where the management focuses on true interdisciplinarity and entrepreneurship and innovation. This is very useful for the attendees who would be willing to kind of generate technologies which are useful to people of a diverse background and people of diverse cultures and interests. This would really augur in a point that there is no disciplinary limitation in conducting academic or applied research.
Correct. Yes.
People, for example, an information technology student should or must interact with a language specialist or a psychologist or a chemist or a physics, because All these things are interrelated. When you talk about the chips, it boils down to the level of silicon. So your kind of talk is very, very interesting and motivating for the people from all disciplines here. And personally, I have observed for graduates of the management school, what you are talking about, the relationship between technology and society, politics, economics, and the culture. Here, the business school teaches them that organizations don't operate in isolation. They operate in an environment which is flooded with political, legal, regulatory, economic, social, and cultural subsystems. So these future and budding managers would also be aware of that, whatever work they do, starting from their executive level to progressing to the CEO, they have accountable to the society because their product development and their interactions are shaped up by none other than the citizens of the society / people / consumers. So there is an element of accountability and there is an element of responsibility on these future graduates that, whatever technology or product or goods and services they generate here or they design here is born out of the society, out of the cultural framework, could be globalized, but should always be accountable to the society from which it has originated, indirectly, hinting at, success of the sons of the soil. So this is my observation, sir, personally, knowing you and also being here in this institution. So that's how my contribution ends. If is there any other question or contribution to the discussion? So we are left with 3 minutes. Sir, if you permit, I will propose my word of thanks on behalf of SRM AP, sir. Can I go ahead, sir? Haribabu, sir.
Yeah, right. Go ahead.
Sir, it was extremely wonderful and very interesting and very insightful interaction with you for the community of SRM AP and the wider community who have joined on Facebook Live and all that. On behalf of the management of SRM University, on behalf of the Vice Chancellor, Pro Vice Chancellor, Deans, Associate Deans and HODs and faculty, especially the ITKM team and HR team who have made this a very grand success event, I would like to profusely thank you for having accepted our invitation to deliver the eminent lecture. Touchwood, Omicron gone, we would like to physically see you here, interact with these budding scientists and senior professors, which will definitely lead to a highly exciting environment to promote social entrepreneurship at the same time, make people regulatory bound and care about the country's culture and language. Thank you so much, sir. We would like to have you here again in person. We will work in that direction. Thank you so much, sir.
Yeah, thank you very much, Kamesh. It's my pleasure, and definitely visit your campus sometime. Yeah. Thank you for all the audience. Right.
Thank you, sir. Thank you. Yeah.
Chat box. I think.
Oh, there are questions in chat box. 1 second.
Lakshman Rao. Yeah. Thank you, Lakshman Rao.
Thank you, sir.
Thank you, sir.